Hello students, welcome to my channel Foundation Mathematics. In this video, I am going to help you out in deriving the multiple and submultiple angles involved in trigonometric functions. Most of the time you find it very difficult to memorize the formula. It is indeed a very difficult task, but once you know how to derive the formula, it is not going to be difficult for you. You should practice it at least for 3 times so that you never forget. Keep in mind all the formula involved in multiple and submultiple angles are based on 3 common formula for sum of 2 angles. So first one is sine A plus B, that of sine A plus B. This is given by sine A cos B plus cos A into sine B. Second one is that of cos A plus B. This is given by cos A cos B minus sine A sine B. And the third one is that of tan A plus B. This is given by tan A plus tan B by 1 minus tan A into tan B. Let me denote the first one by 1, second by 2 and the third one by 3. Now what do we mean by multiple angles? Multiple angles mean it is a multiple of a specific angle. Suppose I write theta equals to 45 degree. Multiple of theta is going to be say 2 theta, which is definitely twice of 45 degree, which is equal to 90 degree. So let us derive the formula for multiple angles first. Let us take A and B to be equal. So let A and B be equal and let this be equal to theta, say. So if we replace A by theta and B by theta in the first one, what do we get? We get sine theta plus theta. What is sine theta plus theta? This is definitely sine 2 theta, and in the RHS we can write sine theta. In place of A we are writing theta, and this is going to be cos theta. In place of B also we are writing theta, plus cos theta into sine theta. So what are we getting? We have got the first formula, which is sine 2 theta equal to sine theta cos theta plus cos theta sine theta. Since multiplication of real numbers is commutative, we can write this simply as twice of sine theta into cos theta. So this is, say, given the number 4. Similarly, if we take the second one is that of cos 2 theta. Cos A plus B, definitely A plus B is going to be 2 theta. So what is the second one? Second one is cos 2 theta. And what is cos A plus B? It is cos A cos B. So in place of A also we are writing theta, and in place of B we are writing theta. So cos A into cos B is cos theta into cos theta. Similarly, sine A into sine B is sine theta into sine theta. So we have cos 2 theta equal to cos square theta minus sine square theta. Right? Let me denote this by 5. Suppose I would like to represent cos 2 theta entirely in terms of cos theta and not in terms of sine theta. What do? I know the identity that sine square theta plus cos square theta equals to 1. So in place of sine square theta, if I have to make a substitution, it can be 1 minus cos square theta, right? So in place of this sine square theta, I will write 1 minus cos square theta. So what do I get? I get cos 2 theta equals to cos square theta minus 1 minus cos square theta. If I open the bracket, I am going to get cos 2 theta equal to 2 cos square theta minus 1. Let me denote this by 6. Suppose I would like to represent 5, that is cos 2 theta, entirely in terms of sine square theta and not in terms of cos square theta. What do? I can write cos square theta as 1 minus sine square theta using this identity. So in place of 6 in the right hand side, I have cos 2 theta. Remember, I would like to represent this entirely in terms of sine square theta. So in place of this cos square theta, I can write 1 minus sine square theta minus 1. So what am I getting? 2 minus 2 sine square theta minus 1. So this gives me cos 2 theta equals to 1 minus 2 sine square theta. Cos 2 theta gives me 1 minus 2 sine square theta, right? So let me denote this by 7. Again, if you have a look at 6, you can write 2 cos square theta as 1 plus cos 2 theta, and from here you can write 2 sine square theta as 1 minus cos 2 theta, just by interchanging the sides. Now what is tan square theta? Tan square theta is sine square theta by cos square theta, right? So tan square theta is basically sine square theta by cos square theta. So we can write this as 2 sine square theta by 2 cos square theta. So now in place of 2 sine square theta, we can write this 1 minus 2 cos 2 theta, and in place of 2 cos square theta, we can write this 1 plus cos 2 theta. So what are we getting? We are getting 1 minus cos 2 theta by 1 plus cos 2 theta. So we have tan square theta equals to 1 minus cos 2 theta by 1 plus cos 2 theta. Simple, right? Next, we will find the value of tan 2 theta. Tan 2 theta is basically tan theta plus theta. That is, in place of a and b, we are writing theta. So what is tan 2 theta? Tan 2 theta is tan theta plus theta. So we have tan a, which is tan theta, plus tan b, which is again tan theta, by 1 minus tan a into tan b. So what are we getting? We are getting tan 2 theta equals to 2 tan theta by 1 minus tan square theta. Let me denote this by 8. Now, I would like to represent sine 2 theta entirely in terms of tan theta. Sine 2 theta in terms of tan theta. What do I get? I have sine 2 theta equals to 2 sine theta into cos theta, right? So, if I divide this whole thing by cos theta, what do I get? I am dividing sine theta by cos theta. So, I need to multiply one cos theta here in order to balance it. So we have 2 tan theta into cos square theta. What is the reciprocal of cos square theta? It is obviously sec square theta, right? Because we know that sec square theta is 1 by cos square theta, or we can write cos square theta as 1 by sec square theta. Okay, so we will write this as sine 2 theta equals to 2 tan theta by sec square theta. And of course, we know this identity that sec square theta minus tan square theta equals to 1. So we have sec square theta equals to 1 plus tan square theta, right? So in place of this sec square theta, I will write 1 plus tan square theta. Thereby, I am getting sine 2 theta entirely in terms of tan theta. So this is 1 plus tan square theta. Sine 2 theta is 2 tan theta by 1 plus tan square theta. Similarly, I can find out cos 2 theta entirely in terms of tan theta. What is cos 2 theta? Cos 2 theta is cos square theta minus sine square theta. So, suppose I have a number a. I can write this as a by 1. So, similarly, cos square theta minus sine square theta can be written as cos square theta minus sine square theta whole by 1. And in place of this 1 in the denominator, I will use the identity cos square theta plus sine square theta equals to 1. So what am I getting? I am getting cos square theta minus sine square theta whole divided by cos square theta plus sine square theta. So definitely cos 2 theta is cos square theta minus sine square theta by cos square theta plus sine square theta. Next, what do? I divide the right hand side totally by cos square theta. So what am I getting? I am getting cos square theta by cos square theta minus sine square theta by cos square theta. And in the denominator also I have the same thing, that is cos square theta by cos square theta plus sine square theta by cos square theta. Obviously cos square theta by cos square theta is 1 and sine square theta by cos square theta is tan square theta. So the numerator is 1 minus tan square theta and the denominator is 1 plus tan square theta. Okay. Now I would like to use these to formulate those for submultiple angles. So what do? In place of 2 theta, I write alpha. So let alpha equals to 2 theta. Then what is theta? Then obviously theta is half of alpha, that is alpha by 2. So first is sine 2 theta. Sine 2 theta is 2 sine theta into cos theta, right? So in place of this 2 theta, I am going to write alpha. So in place of theta, I will write alpha by 2 and in place of this theta also, I will write alpha by 2. So the first one is sine alpha. Sine alpha is 2 sine alpha by 2 into cos alpha by 2. Next is cos alpha. Cos alpha is cos square alpha by 2 minus sine square alpha by 2. So this is basically 2 cos square alpha by 2 minus 1, or this is same as 1 minus 2 sine square alpha by 2. Similarly, tan alpha is 2 tan alpha by 2 by 1 minus tan square alpha by 2. I can write sine alpha in terms of tan alpha by 2. I can write cos alpha again in terms of tan alpha by 2. So obviously sine alpha is 2 tan alpha by 2 by 1 plus tan square alpha by 2, and similarly cos alpha is 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2. Next, I will show you the derivation of sine 3 theta. Now, how do you write 3 theta? 3 theta can be written as 2 theta plus theta, right? So, sine 3 theta is basically sine 2 theta plus theta. So, this is of the form sine A plus B, which is basically sine A cos B plus cos A sine B. So, you have sine 3 theta equals to sine A cos B plus cos A sine B. Now sine 2 theta we have already seen is 2 sine theta cos theta, and you have this cos theta here. So this whole thing into cos theta. And what is cos 2 theta in terms of sine theta? Cos 2 theta is 1 minus 2 sine squared theta. We have seen this. So in place of cos 2 theta, I am writing 1 minus 2 sine squared theta, and you have this sine theta here. So you have sine 3 theta equals to 2 sine theta into cos square theta plus 1 into sine theta gives you sine theta, minus 2 sine square theta into sine theta is minus 2 sine cube theta. How do you replace this cos square theta by sine square theta? Obviously cos square theta is 1 minus sine square theta. So 2 sine theta into cos square theta is 1 minus sine square theta plus sine theta minus 2 sine cube theta. Now little bit of simplification will give you the result. So what you get? You have sine 3 theta equals to 2 sine theta, because 2 sine theta into 1 is 2 sine theta, minus 2 sine cube theta plus sine theta minus 2 sine cube theta. So what are you getting? You are getting sine 3 theta equals to 3 sine theta minus 4 sine cube theta. Similarly, you can find out the value of cos 3 theta, and that is your assignment. You will see that cos 3 theta, if you follow the same process, cos 3 theta is going to be 4 cos cube theta minus 3 cos theta. Check this out. So you see that apparently it is very difficult to memorize the multiple and submultiple angles, rather the formula for multiple and submultiple angles. But if you make a habit of practicing this at least 3 to 4 times, it is not going to be difficult for you to memorize, and you will never forget. So I hope that you have found this video useful. For more such videos, subscribe to my channel. Thank you for watching.